In this video, I'm going to tell you a little bit about my approach toward teaching data structures in this course. So knowing when and how to use basic data structures is an essential skill for the serious programmer. Data structures are used in pretty much every major piece of software. So let me remind you what's the point, the raison d'etre of a data structure. Its job is to organize data in a way that you can access it quickly and usefully. There's many examples of data structures, and hopefully you've seen a few of them and perhaps even used a few of them in your own programs. And they range from very simple examples like lists, stacks, and queues, to more intricate but still very useful ones like heaps, search trees, hash tables, relatives thereof like Bloom filters, union find structures, and so on. So why do we have such a laundry list of data structures? Why is there such a bewildering assortment? It's because different data structures support different sets of operations and are therefore well suited for different types of tasks. Let me remind you of a concrete example that we saw back when we were discussing graph search, and in particular breadth first search and depth first search. So we discussed how implementing breadth first search, the right data structure to use is a queue. This is something that supports fast, meaning constant time insertion to the back and constant time deletion from the front. Depth first search, by contrast, is a different algorithm with different needs, and because of its recursive nature, a stack is much more appropriate for depth first search. That's because it supports constant time deletion from the front, but constant time insertion to the front. So the last in, first out support of a stack is good for depth first search. The first in, first out operations of a queue work for breadth first search. Now, because different data structures are suitable for different types of tasks, you should learn the pros and cons of the basic ones. Generally speaking, the fewer operations that a data structure supports, the faster the operations will be and the smaller the space overhead required by the data structure. Thus, as a programmer, it's important that you think carefully about the needs of your application, what are the operations that you need a data structure to export, and then you should choose the right data structure, meaning the one that supports all of the operations you need, but ideally no superfluous ones. Let me suggest 4 levels of data structure knowledge that someone might have. So level 0 is the level of ignorance for someone who's never heard of a data structure and is unaware of the fact that organizing your data can produce fundamentally better software. For example, fundamentally faster algorithms. Level 1 I think of as being cocktail party level awareness. Now obviously here I'm talking only about the nerdiest of cocktail parties, but nonetheless this would be someone who could at least hold a conversation about basic data structures. They've heard of things like heaps and binary search trees, they're perhaps aware of some of the basic operations, but this person would be shaky using them in their own program or say in a technical interview context. Now with level 2 we're starting to get somewhere. So here I would put someone who has solid literacy about data structures. They're comfortable using them as a client in their own programs, and they have a good sense of which data structures are appropriate for which types of tasks. Now level 3, the final level, is the hardcore programmers and computer scientists. And these are people who are not content to just be a client of data structures and use them in their own programs, but they actually have an understanding of the guts of these data structures, how they are coded up, how they're implemented, not merely how they are used. Now my guess is that really a large number of you will wind up using data structures in your own programs, and therefore learning about what are the operations of different data structures and what are they good for will be a quite empowering skill for you as a programmer. On the other hand, I'll bet that very few of you will wind up having to implement your own data structures from scratch, as opposed to just using as a client the data structures that already come with the various standard programming libraries. So with this in mind, I'm going to focus my teaching on taking you up to level 2. My discussion is going to focus on the operations supported by various data structures and some of the canonical applications. So through this, I hope I'll develop your intuition for what kinds of data structures are suitable for what kinds of tasks. Time permitting, however, I'll also include some optional material for those of you wanting to take it to the next level and learn some about the guts of these data structures, the canonical implementations of how you'd code them up.